Hello my dear class 9 students, welcome back. So today we are going to start a new chapter, and that will be the last chapter for physics portion. So it will be chapter 12, sound. Okay, and you can also refer page 160 to 175. Okay, so sound. So first let's define sound. Okay, so what do you mean by sound? Now the way now I'm speaking, so there's a sound, right? So sound, first the definition, it goes like this. Sound, it is a form of energy. Okay, sound is a form of energy. Sound is a form of energy that gives us, or that produce a sensation of hearing in our ear. Okay, it's a form of energy that produces a sensation of hearing in our ear. So simple. So student, this is the definition of sound. It is a form of energy that produces a sensation of hearing in our ear. Now, so this is the definition. So how sound is produced? Do you know, students? Sound is produced by vibrating object. Okay, vibrating object. It is produced by vibrating object. Clear? Have you observed, how the school bell rings, how the church bell rings? Okay, now I'm sure sometimes if you keep an alarm, okay, an alarm in a table, now suddenly if the alarm starts ringing, you'll hear the vibration, right, along with the sound. So in a simple term, okay, let me tell you that no vibration, no sound. We will not be able to hear any sound without vibration. Clear? Now, in your textbook, there are several activities, okay, which is given. So, one activities which you can perform at home would be just to prove that sound is produced by vibrating object. Okay, in order to prove this one activity, one very simple activity which you can perform is, you can take a book, okay, you can take a book, any book, all book, okay, all book, and what you do is you can take a rubber band, okay, this rubber band, you can take this kind of rubber band, and see, book, and from the longer side, okay, on the longer side, what you do is you just tie this rubber band, okay, tie this rubber band here, and place two pencil here, place two pencil here, okay, on the side. So this pencil will be between the stretched rubber band and the book, okay, and then now you can make your own guitar, right? You can make your own guitar, and now you try to hear the sound, okay. First you'll hear there is a vibration, and then you'll be able to hear the sound, okay. Another thing which we can do is we can take any object like this, okay, because sound, it needs a medium to travel, okay. Now what I'll do is I'll just place this rubber band here. I have two rubber band, okay, two rubber band. See, I have a red rubber band. Clear? See, I have a rubber band here, so you can just do with just one rubber band, okay, and then you can take any medium, okay. So this is a metal, right? So it's a solid medium, okay. Now, can you hear the sound? I'll bring it near the microphone. You can hear the sound, right? So with vibration, there is a sound, okay. So no vibration, no sound. Now you can hear the vibration, right? Right? So no vibration, no sound, okay. Now whenever you speak, okay, whenever if you are singing or if you are shouting, you know, our vocal cord, there is a movement there in our vocal cord, okay, so there is a vibration, and with the production of this vibration, there is a production of sound, okay. Okay, so that is about how sound is produced. Now we'll study how sound travels, okay. How sound travels. So sound, it needs a medium to travel. Clear? Sound, it needs a medium. Now when I say medium, okay, medium means it can be a solid, clear, it can be a liquid, that means water, okay, water. Now it can be air, okay, air. Now the most common one is this air, okay. Now see, now I'm speaking, right? So there are air molecules here present, okay. So through this sound travels. Now sound can travel through solid, liquid or air, okay. So sound needs a medium to travel. That's why it is also, sound waves are also considered to be a mechanical wave. Mechanical waves. Now why I'm saying mechanical wave? Because it needs a medium to travel, okay? It needs a medium. Now without a medium, without this kind of medium, without this solid or without this liquid or without this air, there won't be any sound, okay? Let's take example vacuum, okay? Now in moon, there is no atmosphere, clear? In moon, there's no atmosphere. So now even if you speak something, okay, even if you shout, you won't be able to hear anything. It will be just like this, see, now. So in these 2-3 seconds, were you able to hear anything? No. So it will be like this in moon, okay? Because in moon, there is no atmosphere, clear? So sound, they are not able to travel through this vacuum, clear? They don't pass through this vacuum. So there is no sound in moon. So from there, now we understand that sound, it needs a medium to travel, clear? And how sound travels? Sound travels in the form of a wave, okay? In the form of a wave. Now, that's why it is also known as mechanical waves, okay? Now, if you are asked in exam, why it is known as a mechanical wave? Because it needs a medium to travel, okay? So I'm sure you are clear with this. Now, we'll study about different kind of waves, okay? Different kind of waves. Okay, so students, just now we have discussed about these mechanical waves, right? Now, there are 2 types of waves which we will study here. That is longitudinal wave and transverse wave. Clear? So, longitudinal wave. So just now I've said that the medium can be a solid, liquid and gas, air, right? But which one will be fastest? Sound will travel fast in solid, okay, solid. But which one is the most common one? Most common one is air. Because see, now I'm speaking and the next person here, he is able to hear because of this air, right? Because of vibration and because of the air molecules which are present here, okay? So now this is longitudinal wave and this is transverse wave. So first let's discuss about this longitudinal wave, okay? Okay, so students, now here there is one person, okay? Now he is speaking something here. And here is another, his friend here, okay? So this is the ear, okay? This is the ear. So this is the first person, This is the second person. Clear? This is the second person. Now, so he is shouting. Okay, the first person is shouting. So how is this second person able to hear his sound? Clear? So whenever he speak, okay, whenever he speak, now, like I have said, there are air molecules present, right? Air molecules present here. Okay, these are all, let's take example that these are all air. These are all air. So as soon as he speak, okay, now they vibrate, okay, they vibrate. And these air molecules, what they do, the air molecules, they vibrate each other. It's not that they move from one position to another, okay. They don't shift their position like this, but they just vibrate each other, okay. This person will shake this person will shake another person, this person will shake another person, and in this way, the sound, the second person is able to hear the sound, okay. So this is how sound travels. But now here, I'm going to explain a longitudinal wave. Longitudinal wave example is the sound wave. Okay, the example of longitudinal wave would be the sound wave. Now, let me tell you that the sound, this is, let's say this is the direction of air, okay? This is the direction of air. And the direction of air, it goes in this direction. Clear? So now this person is shouting, right? This person is already speaking out. So the vibrating, the particle, okay? The vibrating particle of a medium is this one. And this is the propagation of wave. See, this is the air wave, okay? This is the air and this is the particle that this guy is already releasing through speaking, okay? Through speaking. So how it is travel? Now you can see that there is parallel, right? The vibrating particle here is parallel with the direction of the air, right? So particle here, okay? Vibrating particle of the medium is parallel to the propagation of air. So this is an example of longitudinal wave, okay? Sound wave is an example of longitudinal wave. And how it occurs? Now, vibrating particle, okay? Vibrating particle means the one which you are speaking out is parallel to the direction of air, okay? So when it is parallel, okay, when it is parallel means it is longitudinal. Parallel longitudinal wave. Clear? Now, transverse wave. Transverse wave. What is transverse wave? Now, transverse wave means, see, this is the direction of air, right? This is the direction of air. And what happens? In this kind of waves, here the particle, okay, the particle will just move up, move down, move up, move down, move up, move down. See, so it is different from the longitudinal wave, right? Here you can see that there is a 90-degree, right? See, it is perpendicular. This is the direction of air and this is the vibrating particle. Now in transverse wave, it is the vibrating particle is perpendicular to the propagation of air, okay, the air. So that is transverse wave. Now this example would be what will happen if you just throw a stone in a water. Clear? So that is an example of transverse wave. Now you guys might be getting with this vibration, oscillation, right? Now, just now I have said that without vibration there is no sound. So, if you are getting confused with this vibration and oscillation, these are same, okay? Vibration and oscillation, these are same. But what is the difference? Now, vibration means both this one are to and fro, okay? To and fro motion of a body. Clear? To and fro motion of a body. But here in vibration there is a sound, and in oscillation no sound. Why? Clear? Because in vibration, okay, in vibration what happens? Okay, let me give you to and fro motion of an object. The simple example would be simple pendulum, okay, or the pendulum that you see in the wall clock, right? It goes like this, see. It goes like this, right? Suppose this is a pendulum, okay? This is a pendulum and this is position A, okay? Position A, this is position B and this is position C, okay? So, to and fro motion means this pendulum, okay, will start his journey from A, right? So, we'll go to B, then we'll go to C and we'll come back to A, okay? C. So, that to and fro motion of a body is known as vibration or oscillation, okay? But why there is a sound in vibration and why there is no sound in oscillation? Because the frequency here is very high, okay? Now, the frequency would be like this in case of like vibration. That's why we are able to hear the sound. But now in oscillation, it has a very low frequency, so it will take its own time. See, now I'm moving, right? So, without producing any sound, okay? So, we can move without producing a sound. So, that can be an oscillation. But here, the meaning is to and fro motion of an object, okay? This is the mean position, so I'm going here, and then I'm going here, then I'm coming back to the original position, okay? Origin. So, that is to and fro motion of a body. So, vibration has high frequency, that's why there is a sound. And oscillation has low frequency, that's why there is no sound. Clear? Okay. Okay, so students, now we'll study about this compression and rarefaction, okay? Compression and rarefaction. So, what happens in compression and rarefaction? Now, just I have said that air particles and whatever we're speaking out, they vibrate, right? And then it passes on, and through this, the next person is able to hear the sound, right? So, see, now, are you able to see this difference? Now, here there is a high frequency here, right? And here it is less. High, it is less. So, whenever you pull a spring, okay, a spring, I'm sure you have tried this one, right? Whenever you pull a spring, sometimes, you know, like there will be a large particle forming together, and sometimes it will spread out. It will form a crowded particle together, and then it will spread out, right? So, this is when they are crowded, okay, and this is when the particle spreads out, okay. Particles being crowded, okay, here, and particles when they spread out. So, this when the particles are crowded, okay, it is known as compression, and when it spreads out, it is known as rarefaction, okay. Now, another example that I will show you from here, okay, another example that I will show you from here. Let's say that this is an air particle, okay, air molecule. So, this dotted line are all air molecule. Clear? So students, this person, okay, this person is already giving out the energy, okay, he is speaking something, so he is giving out the energy, right? Now what happens is that now this air particle, they compress, okay, they compress and then they release, compress, release, compress, release. So now when they are compressed, it is said to be at higher pressure and density. Clear? And when they spread out, it is known as lower pressure and density. Okay, so students, this is the C, this is the R, this is the C, this is the R. Okay, so this is how sound is propagated. Okay, how is sound is propagated and how sound travels in order to to, like, for the next person to hear. Okay, for the next person to hear, it has to pass on, right? So it is how they travel. Okay, so you will see like this: compression, rarefaction, compression, rarefaction. Means high pressure. High pressure is when they are crowded and they come close. Okay, and then when they spread out, that means rarefaction. That means the particles are released. Okay, and then they compress and then they release. That is how sound travels. Clear? So students, in the next class, we'll discuss about the characteristic of sound waves, as well as we'll perform some numerical problem. Clear? Thank you.